In this chapter, I'll talk about covariance and coefficient of correlation. So we're going to talk about the relationship between two numerical values. And we use scatter plots to visually examine the relationship between two numerical variables. And we will discuss two quantitative measures of such relationships. That will be the covariance and the coefficient of correlation. The covariance measures the strength of the linear relationship between two numerical variables. And this is the calculation for covariance if you choose to do it by hand. This is for sample covariance. So basically what you do is you take the mean of your x values and the mean of your y values and subtract them from their corresponding x and y values. You add them all up and then you divide by n minus 1. So the covariance is only concerned with the strength of the relationship, and no causal effect is implied. Basically, the covariance tells you what direction your variables are moving in. So if you calculate a covariance that's greater than 0, then that means that your x and y tend to move in the same direction. So in other words, as x increases, y increases. As x decreases, y decreases. If you calculate a covariance less than 0, then that means that your x and y tend to move in opposite directions. So as x increases, y decreases. As x decreases, y increases. And if you calculate a covariance of of 0, then that means x and y are independent. It's just random. They're not dependent on each other. So the covariance has a major flaw. It is not possible to determine the relative strength of the relationship from the size of the covariance. And this is where the coefficient of correlation comes in. And this measures the relative strength of the linear relationship between two numerical variables. So this is the formula for the sample coefficient of correlation. You take the covariance and you divide by the standard deviation of your x times the standard deviation of your y. So of course these calculations are very tedious. We are not going to do this by hand. But let me talk further about the coefficient of correlation. The population coefficient of correlation is referred to as rho. Remember, we use Greek letters to talk about population. For the sample coefficient of correlation, we use the letter R. Either rho or R have the following features. It's unit free. They range between -1 and 1. The closer you are to -1, the stronger the negative relationship. The closer you are to 1, the stronger the positive linear relationship. And the closer you are to 0, the weaker the relationship. So here are a few diagrams to show you how your graph may look with the following correlation coefficient. So if R is -1, you have a perfectly straight line. Okay? If you look down here below it, when R is +1, you also have a straight line. The difference is when R is equal to -1, it slopes down. So that's a negative. As x increases, your y decreases. And when your R is +1, as you can see, it slopes up. As x increases, your y increases. Then you can have any value of R between -1 and 1. When R is -6, as you can see, you have scatter. The scatter is sloping down, but it's still scattered nonetheless. And that's why you would have a negative R. If you look at this next one, R is equal to 3, it looks like the graph is sloping upwards. But it's a lot of random scatter, so it's not really a strong relationship. So that's why R is kind of small, it's 0.3. And then here, the last one, R is equal to 0. It's just a straight line going straight across, but you can also have just random scatter, like dots all over the place. That will also be R is equal to 0. So let's go through a problem. The following table lists the calories and sugar in grams in one serving of 7 breakfast cereals. Okay? So for example, Kellogg's All Brand, it has 80 calories and it has 6 grams of sugar. Okay? If you look at the bottom, we have the mini wheats, the calories is 200, and the amount of sugar is 10 grams. So we want to calculate the covariance and the correlation of coefficient. So I will show you how to do this in StatCrunch. I already have my variables listed. So what we will do is we're going to go to Stat, Summary Stats, Columns. We're going to select calories and sugar. Oh no, I'm sorry, that's not what I wanted. I want Stat, Summary Stats, and I want to go down here to Covariance. I'm sorry about that. We want covariance. So if we click on that, now we can select calories and sugar and hit compute. And it gives me a value of 133.33. Okay, so as you can see, that's greater than 0. So that basically tells me that my x and y variables are moving in the same direction. As calories increase, so do the amount, so do the grams of sugar also increases. Okay. If we go ahead and do correlation coefficient, we're going to go to Stats, Summary Stats, and then we're going to see something that says correlation. And we click on that, we're going to select these two variables and hit compute. And it gives you R value of 0.8391. Okay, so I'm going to go ahead and write this information on my slide. We had a covariance. We said it was 133.33. That's greater than 0. So that means as one variable increases, the other one increases. And we got an R of 0.8391. Okay. I'm also going to show you how to do this in our Excel template. I already have a template for this. So all you have to do is put in the calories and then the sugar. So you have to make sure they match up. So remember, we had 80 calories, 6 grams of sugar. So they have to correspond to each other. You can put one variable in column A and the other variable in column B. And once you do that, it will automatically calculate your covariance and your correlation coefficient. You can click on the actual answer to see the command that was used. Since we're doing sample, this command says covariance.s. S stands for sample. And then when you do correlation, that's the command, CORREL. And you have to indicate what columns you're using for the calculation. So we have A and B. So if you go back, since we have R is equal to 0.8391, that's really close to 1. Not too close, but it's close to 1. So that indicates to me that this is a strong positive correlation. And that's what we said before. As one variable increases, the other one increases. And which makes sense, because as your calories increase, so does the amount of sugar, or vice versa. The more sugar you have, the more calories you're going to have. And that's indicated by this information on this chart.